Okay. तो हमें न्यू टॉपिक स्टार्ट करना है, रिएक्शन kinetics, which is also called rate of reaction. Basically, reaction kinetics is the study of rate of chemical reaction. That how during the course of a reaction a rate would change or rate varies. Next, we have rate of reaction. So we can define it as a change in amount of reactants or products in a unit time. So it means how much amount of reactants are consumed or how much amount of product is formed in a unit time is called rate. Is this understandable to all of you? Okay. So rate of reaction we can say that change in amount of reactants or products over time. It is rate. Okay. Then see, it is change in amount. So the unit can be, if the change is, we are observing the change, that is the change in mass, then it is gram per second. And if we are measuring the volume of a gas in a unit time, so the rate will be centimeter cube per second. Or if we are observing or recording the change in concentration, so it is going to be mole per dm cube per second. And in most cases, we use this, that change in concentration over time. Is this understandable to both of you?
Yes.
Okay. Now, before heading towards the factor, first we will discuss collision theory. So what happens during a chemical reaction? What reactants do with each other? They will turn into product, but that uh, turning into product is only happens when the reactant particles collide with each other. The reactants, when they undergo collision, then this will happen. So during a chemical reaction, the reactant particles must collide with each other if the reactant particles do not have enough energy. And what does means by enough energy? Enough energy means by that they must have a energy which is equals to at least activation energy or greater than this. So then on collision, reactant particles simply bounce back without changing into product. We call this kind of a collision unsuccessful collision. Is this clear to both of you, Kubra and Amna?
Yes, sir.
Yes, Amna, did you understand? Okay. Now, if the reactant particles have enough energy, and enough energy means that energy greater is equals to activation energy. Then on collision, reactant particles turn into products. And this kind of a collision, when the reactant particles turn into product, we call it effective collision or successful collision. Is this clear?
सर एक्टिवेशन एनर्जी से ग्रेटर हो सकती है एनर्जी?
Yes, obviously that is the minimum requirement. So you can, in this case, it is either equals to or greater than. That is the case. Enough energy is the activation
Okay.
energy. If the particles do not have that much energy, then they do not turns into product. But if the particles have that much energy or greater than that, in both the case they turn into product, and that is a successful collision. Is this clear?
जी सर.
Okay. Now we have what is activation energy. We can say it is a minimum amount of energy that reactant particles must possess for a successful collision. So you have done these diagrams for the with the catalyst in your O levels as well. So here we have enthalpy on y-axis, and here we keep reaction path on x-axis. For example, if the reaction is exothermic, this is the energy of the reactants, and this is the energy of the product. And the reaction proceed in this way. So here we have a reactants, here we have a product. From reactant till the highest point, it is activation energy, that is without catalyst, right? And from reactants till product, it is enthalpy change. When we add a catalyst, what will happen? It provides an alternative path with a lower activation energy. So this is the lower activation energy in the presence of a catalyst. Is this clear to all of you?
जी sir.
Okay, so this is for an exothermic reaction, right? And here it is for an endothermic reaction. Where the reactants have a lower energy, the products have a higher energy, and reaction will proceed in this way. So from reactants till the highest point, we have a activation energy without a catalyst. Here we have reactants, here we have a product. From reactants till product is the enthalpy change, and when the catalyst will added, it will lowers the activation energy by providing a new path, and for which less energy is needed. So this is the new activation energy which is with a catalyst. Is this clear?
जी sir.
Yes, Amna? Okay. Now, if we look back to collision theory, it states that when the successful collision occur, product will form, right? Yes. So,
Yes, sir.
and if the successful collision occurs more frequently, it means they occur with a greater frequency, then more product will form in the lesser time.
Yes, sir.
So it means that rate of the speed will become higher when the successful collisions frequency increases, right?
Mm.
So we can conclude over here that according to the collision theory, rate of reaction increases when frequency of the successful collision increases. Is this point is understandable?
Ji, sir.
Okay. Then the other thing that if will have a higher proportion of the molecules having energy equals to or greater than activation energy, then it will also lead to more successful collisions per unit time and hence the rate will increase. So these two are the factors, either the frequency of the successful full collision increases or higher proportion of molecules having energy equals to or greater than activation energy, then it will also lead to increase in rate of reaction. Is this point is clear?
Ji, sir.
Amna, is this clear to you as well? You can WhatsApp me if your mic is not working, okay? Okay. Now, the first factor which can affect the rate of reaction is concentration. So for concentration, we usually use two terms. One is diluted and second one is concentrated. I hope you guys know what does diluted and concentrated means. Can you guys just give me a minute, please? Okay. So we have a either solution can be considered as diluted or concentrated. If the solution is diluted, it means less number of moles per unit volume and concentrated solution means more number of moles per unit volume. Is this understandable to both of you?
जी सर.
Okay. So when there are less number of moles, per unit volume, so the less number of moles per unit volume means that the particles are further away from each other so less number of, or we can write lesser frequency of collisions. And if the lesser frequency of collision is there, then what will be the rate, higher or lower?
Lower.
Yeah, lower, very good. Hence rate of reaction is lower. Now, in concentrated solution, particles are closer to each other and as a result, greater frequency of collisions. You can write successful collisions as well. And as a result, rate of reaction is faster. Yes, is this clear to all of you?
Yes, sir.
Okay. Then we have a next factor, that is pressure. So pressure can affect only those reactions in which gases are reactant. Okay, the further, and its affects the same way as the concentration of a solution do. So it means if the pressure will be higher, then the gas particles are closer to each other, and when they are closer to each other, the frequency of the collisions will be higher and the rate of the reaction will be faster. And if there is a lower pressure of the gas, the particles are further away, and as they are further away, the frequency of the collision would be lower, and as a result, the rate of reaction is slower. Is this clear?
Yes, sir.
So I'm just not writing it. You will explain it in the same way as we explained concentration. Okay. Now, next factor is catalyst. So we know that catalysts are substances that speeds up the rate of reaction.